learning for plane figures for the polygon or parallelograms and the triangles. At the top, please put your date that you're looking at this and filling it out, as well as your name, your period, and the number you are for your period. If you don't know the number, you can leave that blank, but please be sure to put the period that you have. In the back of room 1029 are, in the blue compartment, is the paper for the relearning that you have for this standard. If for some reason you're watching this at home and you don't have the paper with you, you can rewrite it on lined paper and hand it in after we're done. The directions for there's two main factors that we have to keep in mind for the parallelograms and for the triangles. We're looking for especially for parallelograms, when they're next to each other, they add to 180, and when the angles are across from each other, they are equal. Next to each other, they're 180, and across from each other, they're equal. When we're looking at triangles, there's a little bit special things. We'll look at those for number 2, but right now we're just looking at the parallelograms. In the directions up here, it says solve for x. Sometimes we have to put the x back in and solve for the angle measurements, but today on this problem, we only need to solve for x. So I'm going to bring this in a little bit closer so that you can see. So we're looking at 8x plus 40 and 6x down here. Since how they're next to each other, this angle would also be next to each other, to this one here. We're going to put them as 8x plus 40 plus 6x equals 180. You'll notice that in geometry, 180 and 90 are key angle measurements. 180 are key angle measurements. Most of the angle measurements that we're interested add up to 180 or 90. If we were to have all the angle measurements, that's when they add up to 360, but we only need 2 to be able to solve this to get to 180. 8x plus 40 plus 6x will give us 180. To solve this, we solve this as we do all our algebra problems. We take the 8x plus the 6x, which gives us a 14x plus 40 equals 180. You're going to subtract 40 from both sides. We have 14x equals 140. This is what times 14 equals 140. We're going to divide both sides by 14. Divide both sides by 14, and you can see that x will equal 10. Now, because the directions asked for x, we are done. If it asked for the angle measurement, it would be 8 times x, and our x is 10, plus 40 would give us this angle measurement up here. So when they're next to each other, they're 180. When they're across from each other, they're equal. Looking at triangles, triangles are half of a square, but they are also 180. Each angle measurement added together, we need all three, angle M, angle V, and angle Z. You need all three measurements to add to 180. So we have 5x plus 3 plus 6x minus 15 plus x equals 180. All triangles, all the angle measurements inside always add to 180. 5x plus 6x, and now remember we have an x here, but the coefficient in front of it is a 1x. 5x plus 6x is 11, plus this 1x gives us our 12x. Positive 3 plus a negative 15 is a subtraction of 12 equals 180. This is our simple algebra problem that we're looking for here. We're going to add 12 to both sides. We have 12x equals 192. Now, subtraction of 12 and an additive of 12 give us 0, so they cancel out. We're in effect moving the 12 from one side of the equal sign to the other. This down here tells us that 12 times what equals 192. So we're going to divide both sides by 12. We do our math over here on the side. 12 goes into 192. 12 goes into 19 one time. Subtract these and we get 7. Bring down the 2. 12 goes into 7 6 times. Our x equals 16. Now we need to go back up and read our directions, because even though we've solved most of the problem here with x equals 16, we need to look up here at the top. It says find the value of angle V. Well, this is angle V up here at the top. X does not give us angle V. Angle V is 6 times whatever x is, 16 in this case, minus 15. So I'm going to just go off to the side here and do my measurement or my math for 16 times 6. 6 times 6 is 36. Carry the 3. We have 96. So the angle V equals 96 minus 15. Subtract 15 over here in the corner. We subtract these out, we have 1 and 81. So the measurement of angle V equals 81. And that's our final answer. At the top on number 1, they only asked us for x. And number 2, I'm asking for you to find V. So we have to plug it back in. Looking at right here on the length of ST. Now on these measurements here, when they're across from each other like this, they are equal to each other. So we have 2x plus 15 plus x plus 15 will give, oh, here I wasn't paying attention. Let's do it again. 2x plus 15 equals x plus 15. Remember, they're equal. It's very easy to go down this road where we're going to have them add to 180, but they aren't. When they're across from each other, they're equal, and we're looking for the length of the line. Remember that this x right here is a 1x. 1x. So I'm going to subtract that 1x from both sides. So that gives us 1x plus 15 equals 15. Now this seems a little odd, but it's okay. You just keep on going from there. Subtract 15 from both sides. We have 1x equals 0. Well, this can happen. Our x will equal 0. So what does that mean? That the angle ST, the line ST is equal to 2 times 0 plus 15. That's still a positive number. ST, it's a length. It's not an angle. The length of the parallelograms on either side are equal. So the length of ST, the line segment ST, is equal to 15 because 2 times 0 plus 15 gives us our answer of ST equals 15. On the back side here, we're looking for the measure of angle G. The measure of angle G. Now these two angles that are given to us are across from each other. When they're across, they're equal. When they're next to each other, they add to 180. So we're going to look at this here. 5x minus 9 equals 3x plus 11. Now if you're struggling with how to solve equations like this, in the standard parallelograms cut by a transversal, I've included a little bit of how to solve these algebra problems in there, and a little bit of a review in those problems. So I suggest that you look at that video in the Para Relearning, that parallelograms cut by a transversal, and they'll help you with solving equations with variables on both sides. Because the x is on both sides and they're not next to each other, we are going to have to subtract x, whatever our x is. In this case, it's 3x from both sides. Subtract 3x from both sides. So we're given 2x minus 9 equals 11. This 3x plus a negative 3x is 0. 5x minus 3x equals 2x minus here. So we're going to add 9 to both sides. And that gives us 2x equals 20. Divide both sides by 2 in case you didn't see that 2 times whatever x is equals 20. Well, we can see that that's 10, but if you don't see, you divide both sides by 2. X equals 10. Now in here, we're looking for the measure of angle G, which is right here. So finding x gives us the key to unlock what the measurement is for angle G. So 5 times 10 minus 9 will give us our measurement of angle G. 5 times 10 is 50 minus 9 will give us a 41. The measurement of angle G is equal to 41, and that's our final answer. So recap on here. There are two methods. On the first, they're next to each other, so therefore they add to 180. When we have a triangle, those all add to 180, the angle measurements. When the line segments are across from each other, these are equal. We set those to being equal, which would be what we're doing down here. They are across from each other, therefore they are equal. The measurements are. If these lines are, if SR and TU are parallel, then these must be the same distance apart. On the back side, when the angle measurements are across, you have to set them equal and solve it with variables on both sides. You have two examples here that are yours on the You Try, number 5 and number 6. I also would like you to write down here to let me know that you've seen the video all the way through. Write the 3 types of problems that we are solving for this standard. I need to see that at the bottom so I know that you've done that and you've thought these things through. Thank you.